So hi again everyone. In this video we'll tackle an FE style electricity problem, a great refresher on electric circuits if you're getting ready for the FE mechanical exam. And for sure we're going to be solving more in this playlist. So we're given two resistors, one of 3 ohms resistance, let's call it R1, and the other is of 6 ohms resistance, let's call it R2. R1 and R2 are connected in parallel across a 12 volt source, and we're asked what is the total current in amperes. Now, to help you understand what's going on, I'll sketch the circuit diagram, although you don't need to in this question. So this is R1, the 3 ohms resistance, and this is how we sketch it in parallel with the 6 ohms resistance we called R2. And because we're given they're connected in parallel across a 12 volt source, we extend the circuit and we sketch the source in this way. And let's not forget that we're given the value of the source, which is 12 volts. And now it's time to find the total current in this circuit. So step 1 is to find the equivalent resistance for R1 and R2. And in step 2, we apply Ohm's law to find the value of the current I. So let's work out step 1, which is calculating the equivalent resistance R equivalent. Now, of course, if you're taking the FE mechanical exam, you could look this formula up in the FE reference handbook. But by the time you're sitting for the exam, it's really something you should know by heart. It's a simple and easy formula, and knowing it offhand will save you time flipping through the handbook. But because we're practicing now, it's a good practice to get used to searching the handbook. So in the reference handbook, let's go to the electrical section and find the equivalent resistance formula for parallel resistors. As you see here, this is the section for resistors in series and parallel. There's like a shortcut formula we can use for only 2 resistors in parallel. So we're going to be applying this formula because it's the case in our problem. So R equivalent equals R1 times R2 divided by R1 plus R2. Now plug in the values. R1 is 3 ohms multiplied by R2, which is 6 ohms, divided by 3 plus 6 ohms. Of course, the final unit is ohms, which is the unit of R equivalent, and it's seen here clearly. Mathematically speaking, in the numerator, there's ohms multiplied by ohms, and in the denominator, there's only ohms. So ohms above crosses out with ohms below, and what remains is ohms. Now you may use a calculator to find the value of R equivalent. But it's easy to notice here that above you have 3 times 6, which is 18, and below you have 3 plus 6, which is 9. So 18 over 9 ohms equals 2 ohms. Finally, the only thing left is to calculate I. So we hop on to step 2 and we plug in the values of R equivalent and the source V. R equivalent, we already found it, it's 2 ohms, and V is given to us as 12 volts. Current I is then equal to V over R equivalent equals 12 volts divided by 2 ohms, which results in 6 amperes. So the correct answer is choice D.